log A equals to 1. Okay, the other one will be log A1 equals to, okay, good. These are both correct, but do you know why? You read the textbook, right? How can you not know why? How can you just blindly accept this without knowing why? Okay, so like I said, logarithms is closely related to the exponential form. When I give you a question, for example, log 2 8, log base 2 8. Now, this must be what is going through your mind. There's an unknown here, right? There's a question mark. And of course, we usually leave a question mark as x in our secondary school. So what does this log base 2 8 equals to x mean to you? Okay, so you must be able to convert this quickly. 2 to the power of x equals to 8. Okay, 2 to the power of x equals to 8. So what is the value of x? 3. 2 to the power of 3 must be equal to 8. So when I give it to you like this, just log base 2 8 equals to, then I want you to train yourself to think this way. Always think this way. 2 to the power of something is supposed to be equal to 8. What is that something? Every time you see log, you ask yourself that question. 2 to the power of something equals to 8. What is that something? It makes it easier for us to accept. Rather than you see the word log, oh, log, my seniors tell me log very difficult. Wow, my friends from another class learn log already, say very difficult, so I think it's very difficult also. Nonsense. Okay? This is basically 2 to the power of something. What is that something? And every single one of you are able to tell me that it is simply 3. Right? Simple. Okay, let's go back to this example then. The first one, log base A equals to, so what should be going through your mind? A to the power of what equals to 8. So what's the answer? 1. A to the power of 1 must be equal to A, right? No other option already. That's what we have over here, 1. Okay? Now let's try for the next one. A to the power of what equals to 1. So then you connect the dots and you say, oh, A must be equal to 0. Oh, sorry, A to the power of 0 must give us 1. And that is where we get these from. Okay? So now that we have this information, we can switch them to the exponential form just to verify. So A to the power of 1 equals to A. A to the power of 0 equals to 1. That is why your laws of indices must be very strong. Do not, and I say again, do not start on log when you have very weak fundamentals for indices. But I don't expect you to just zone out and start doing your indices right now. You try and follow as much as you can. And if you do know that your indices are weak, you go back and revise. Otherwise, you'll be in trouble over here. Okay? So with this, you should be able to do your questions that were assigned to you yesterday. Right? Okay, next one. I love to use this property. It allows me to rewrite numbers. For example, in an equation, blah 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 blah, then plus a 7. So for example, over here I've got blah blah blah, then equals to log base 6, for example, if something. Then in the question itself, I also have some more log base 6 with something over here. Okay? Then I see the number 7. Intuitively, right, what would you like to do? Would you like to have the number 7 over there? Or would you like to have it in terms of log base 6 as well? Because everything is in log base 6, right? I would like to be able to change this to a log base 6. Okay? So this is one of the ways that we can introduce a log base 6. Let me show you how. Maybe let me change the question. I change it to something simpler. 1. You know how to change this to log base 6? You know, Okay, so this will be, instead of plus 1, I'm going to change it to become log base 6 with 6. Get it? So what if it was a 7 instead? Let's say it is a 7. So then this becomes 7 times 1, which is 7 times of log base 6 with a 6. Then later today, I'll teach you how to convert this to get rid of the 7. Get rid of the 7. Okay? Next. I mentioned this number 2 days ago. Can you use your calculator to find out what this value is again? Just give me the first 5 digits. 7182. Is it? Okay, okay, 183. Okay, round off. So I told you that this is a very special number. Let me just a power mn, right? Sorry, m plus n. Our first law of indices that we learned. All very, very familiar with this. And then we learned that logarithms is another way of writing exponential, isn't it? Logarithms is another way of writing it. We say that, what was the example that we always use? Let's come up with something else. A to the power of, for example, m. Let's say this is equals to x lah. X equals to a power m. So when I convert it to log form, I get m equals to log base a x. Right? So our logarithms is a way of rewriting it such that I make the power the subject, because I always want to find the power. Now I'm going to highlight the powers. Can we try to find a relationship between, or rather, can you try to rewrite the exponential form a power m times a power n equals to a power m plus n into a log form?
Yes.
How?
M plus n equals log ax.
M plus n equals to log base a x. Are you sure? No, not really. So this is your task right now. And I give you a clue. Let, what did I say? X equals to a power m. Y equals to a power n. Z equals to a power m plus n. Right, so from the line in red, which disappeared, okay. Here I can change it to a log form. M equals to log base a x. I also have n equals to log base a y. From here I also have log, m plus n equals to log base a z. Now, I am interested in the powers. That is why I am doing this. Can you form an equation with this using substitution? Yes, right? Okay, tell me the equation. Equals to log az. Good. But now I have so many unknowns. Is there something that I can do to replace with something else? For example, this z. I don't want so many unknowns. Z, what can it be replaced by? What is z supposed to be equal to? A power m plus n, right? Which is actually the same as this one, right? Which is the same as this one. Which is the same as x times y, isn't it? Z equals to x times y, right? So this z is now replaced by xy. When I write it this way, I am saying that there's a bracket over here. Log base a xy equals to log base a x plus log base a y. This is a property that you need to know. This is our first law for log. Okay? Okay, textbook. There should be a... We are using this formula over here. Log base a x plus log base a y equals to log base a x times y. So for part A, Are you adding two logarithms up with the same bases? That's why you need to ask yourself, are you adding two logarithms with the same base? Yes, then I can apply this. I'm adding two logarithms with the same base. I will get the same logarithm with the same base. So here I've got log base 2, log base 2. My result will also be log base 2. Then now I need to fill in the next part. It is supposedly xy. X times y. Where did they come from? The first log and the second log. Multiply the two numbers together. 3 times 7. So you get log base 2, 21. This is our answer. Okay? So for part B, we can do it faster already. This is since I'm adding logarithms with the same bases, my final answer will have a logarithm with the same base. And this is actually 2p times q times 5q, which can be simplified to become 10pq squared. Part D. Log base 4, half times 8, 0.5 times 8. Log base 4, 4. And this is a special logarithm. It will give us 1. Okay? Yes? You mean without this? Or you mean like this? Because you do mental sums? In this case, quite obvious lah, so you can. If it gets more complicated, then I need you to show more steps. Okay? If this is a 2-mark question, then I expect you to write down log base 4, 0.5 times 8. So that you show you know how to get it. Log base 4, 4 equals to 1. Okay? What about part C that I conveniently left out? What is the question again? Log base 5, 8 plus log base 6, 9. Okay. I have addition of two logarithms, but do they have the same bases? No. This one and this one, they are different. So I cannot apply my law over here. Can? Okay, next one for you to discover. A to the power m divided by a to the power n. What does this give us according to our indices? Okay, now your job is to find out the equivalent in logarithms. So again, we'll let x be equals to a power m, y equals to a power n, z equals to a power m minus n. Do the same. Right. So from here, we convert this to logarithms. M equals to log base a x and log base a y. M minus n equals to log base a z. Again, we are looking at the powers. There is a relationship between the powers. And they're found here. So doing simple substitution, m minus n. M minus n, So log base a x minus log base a y must be equal to log base a z. And now this z over here is supposed to be equal to a power m minus n. This whole thing is supposed to be z. Okay, which is actually the same as x over y. A power m divided by a power n. So now this z is replaced by log base a x over y. This is our next law that we are learning.